You know, building a modern cloud-native application is a lot like assembling a high-performance machine. You can't just have an engine, right? You need a complete state-of-the-art toolkit with specialized instruments for every single task. Today, we're going to pop the hood and open up that toolkit for the modern Java developer.
So, that's the big question we're tackling. When you're building applications that are meant to be scalable, resilient, and deployed anywhere in the world, what are the essential frameworks you absolutely need to have at your fingertips? All right, let's open up the toolbox and see what we've got. We'll start by laying down the core foundation. That's the engine of our application. Then, we'll get fancy and add some intelligence with AI. After that, we'll bolt on some rock-solid quality controls, and then figure out how to ship it all to the cloud. And finally, we'll see how all these pieces fit together to create the whole ecosystem.
First things first, we're talking about the absolute heart of our machine. Before we add any of the cool bells and whistles, we need a powerful and reliable engine to build on. And in the Java world, that foundation is Jakarta EE.
Now, what's really cool about this is that Jakarta EE isn't just one single product. It's a set of specifications. Okay, so what's a specification? Think of it like a universal blueprint. It's an agreement on how something should work. This means you can write your code against a standard, and it'll run just fine whether you're using Wildfly, OpenLiberty, or Payara. It's all about avoiding vendor lock-in, and it's a huge reason for the platform's stability.
But here's the thing. You don't always need the biggest, most powerful engine for every job. For building really lean, fast microservices, you start with the core profile. Think of it as just the bare essentials. You get the minimum APIs for things like dependency injection, REST services, and JSON processing. It's designed to be incredibly lightweight and start up in a flash, which is exactly what you want in a cloud-native world.
Now, building on top of that foundation, the next layer in our toolkit is the web profile. This takes everything from the core and adds the tools you need for more traditional web applications. You know, things like Jakarta Servlet for handling web requests and Jakarta Persistence for database access. This is the real workhorse for a ton of Java apps out there today.
And finally, you've got the full Jakarta EE platform. This is the whole shebang, the complete package with every single specification included. It's built for those massive, multi-tier enterprise systems. We're talking about the big applications where the user interface, the business logic, and the data storage are all their own separate, independent layers. This really shows how the platform can scale. It gives you a tailored toolkit whether you're building a tiny microservice or a huge, sprawling application.
But let's be real. Running an application in the cloud brings a whole new set of challenges, doesn't it? You've got to deal with network failures, services that might just stop responding. Your app needs to be resilient, and you need to be able to see what's going on inside it. That's where MicroProfile comes in. It's like a companion set of specifications that supercharges Jakarta EE for the cloud. It adds critical features like fault tolerance to handle network glitches, health checks so Kubernetes knows if your app is okay, and telemetry for deep observability. The two work hand in hand to create a truly awesome cloud-native platform.
Okay, so our core engine is running and we've got our cloud-native enhancements in place. Let's open the next compartment of our toolkit. It's time to give our application a brain by hooking it up with some artificial intelligence.
And believe me, the Java ecosystem is absolutely packed with powerful AI and machine learning frameworks. For example, if you want to build a chatbot that uses a large language model like GPT, you'd reach for LangChain 4j. For more general machine learning, there's the Deep Java library. And for really specialized problems, you have tools like Optiplanner to solve super complex scheduling puzzles, or Drools for building systems that make decisions based on a set of rules. Pretty cool stuff.
A smart, powerful application is worthless if it's not reliable, right? I mean, who cares how cool it is if it crashes all the time? So, our next set of tools is all about quality assurance, making sure everything we build is tested, stable, and totally ready for production.
So when it comes to quality, we basically have a three-layered approach. At the base, you've got JUnit. It's the absolute standard for writing automated tests in Java. Then, to test individual pieces in isolation, you use a framework like Mockito to create mock objects that pretend to be other parts of your system. But for the ultimate in realism, you have test containers. This library is amazing. It lets you spin up real Docker containers, like your actual database, during your tests. This ensures that what you're testing behaves exactly how it will in the real world. We've built it, we've made it smart, and we've tested it. Now it's the moment of truth. It's time to get our application out into the world. This means looking at the frameworks for packaging, deploying, orchestrating, and of course, securing our services in the cloud. The whole process starts by packaging our app into a portable container using a tool like Docker. Think of it like putting our app in a standardized, sealed box. Then Kubernetes steps in as the master orchestrator. It's like the conductor of an orchestra, telling all these little containerized boxes where to go, how many copies to run, and how they should talk to each other. And finally, to lock everything down, a framework like Keycloak acts as a security guard, managing who gets in and who doesn't to make sure only the right users and services can access it.
So now that we've seen the full toolkit, let's just take a step back for a second and see how it fits within the bigger Java ecosystem, especially when you compare it to other popular choices out there.
A really common comparison is with Spring Boot, and the key difference really comes down to philosophy. Jakarta EE is all about being standards-based and vendor-neutral, and it's supported by a bunch of different companies. This gives you amazing long-term stability and portability. Spring Boot, on the other hand, gives you opinionated defaults to simplify configuration and is mainly driven by one company, which offers a ton of flexibility. Honestly, they're often more complementary than competitive, and if you know one, it's pretty easy to pick up the other.
So let's pull it all together. What's the big takeaway here? The modern Java toolkit with Jakarta EE at its heart is a complete and really powerful ecosystem. It gives you a standardized, modular foundation that can scale from tiny microservices all the way up to massive enterprise systems. It becomes truly cloud-native thanks to microprofile, and it's surrounded by this rich universe of frameworks for AI, testing, and deployment. And maybe most importantly, its core promise of vendor neutrality gives you the freedom and flexibility to build for the long term.
So there you have it. We've laid out all the tools on the workbench. A powerful core engine, specialized instruments for intelligence, quality control, deployment, and security. The only question left is, what amazing thing are you going to build with it?